again. Okay, so what I'm going to do, guys, I'm going to walk you through this this quick project that we do, and this actually the presentation was done a couple of years ago by some of our students, and I thought it represent exactly what you're looking for. So what I'm going to walk you through is an apartment building, quadruplex, designed electrically, and we have all the layout of the receptacles, the layout of the lights, the layout of receptacle lights, switches, and circuitry. So, and a couple of symbol sheets that we use, and how the system operates, and a couple of cut sheets and one-line diagram. So, like you guys, you have the one-line, the title block. We call it title block, and we have the first page of the title block. This is the E's. You guys are the A's, right? We have the E's, the A's, the M's, and the environmental, and the S's and structural. Yeah, thank you. Everybody knows that, how the system is put together. You guys, the architects, always put it together. We have, when we submit a project, there are two things that you submit: the CSI specifications, and Tim is an expert in that area, where every discipline have to submit their own specifications, and a set of drawings. Each discipline has to submit set of drawings. These are ours. So if you look at the stuff, these are all the E's that we have at the beginning. I'm going to walk you through each one of the E's. So E1 is going to be our, what we call it, the list of electrical sheets, the title sheet for us. E2 is all the symbols. If you're interested in the symbols, I know it's hard to see here. I can email it to you in a CAD format or any other format that you want. Let me know, and I can send it, because it's hard to see them here. But these are basically, these symbols are taken from Shad Cooley Erickson, one of the largest electrical engineering firms in the I think they're in the Midwest almost, excluding Chicago.
I would have created some of those right away in AutoCAD.
Is it? Okay. These are all, so these are the symbols that we use. And then what we did, so the first sheet is you put the symbols, right, to show the people what, everybody knows what the symbols, why do we use symbols? Because we don't have enough language or enough space to write a description of every single thing that we need on a piece of paper, right? So if we need a light, we just show a rectangle. If we need a receptacle, we show like a dollar sign. There's a lot of things that we show as symbols to represent our electrical system, exactly like the architects do. So you can, on the right side here, you're going to have the abbreviations. We abbreviate a lot in the electrical and in every industry, construction. You can abbreviate anything you want as long as you have abbreviation lists, so I know what you mean. Does that make sense? When you see anything abbreviated, electrically, it's going to be an abbreviation, electrical abbreviation list. Okay, then the second thing that we start, so we have what we're going to be the overview picture of the whole project. Then we go down into the symbols that we're going to use in the abbreviation. And the second one, my friend, is the site plan. We have a site plan. This building, this structure, or this site has three structures, as you can see. We have the garage building, we have a swimming pool. It's an apartment building, by the way, and we have the structure of the building itself. The building is a 5,000 square foot quadruplex. And you know what quadruplex is, all right? 4 apartments sharing different entrances. So you get into the building code and all this stuff. So this is what we need to power. If you guys can see, if I can grab my very quick here on this side. Does it want to load? Okay, let me see if I cannot load the file. Okay, alternative methods. There's always alternative, right? Okay, so if you guys can see right here, we're bringing power. I don't know if you can see from here and here. We're bringing power and low voltage into the building. Can you guys see that? These lines are bringing power to the buildings. Why two? Because we have one line for power and one line for low voltage. We don't put them in the same conduit. So you guys don't go, I don't know if you go into, that's the start point, is bringing power to the building and low voltage, as in coaxial cable, phone, or fiber optics. You need to bring the building some type of a wire, definitely for the power, and most likely will be for the low voltage, for the telecommunication, for data, as well as phone, right? So these are the two trenches that we're going to bring the power to the building. Then
that comes from the easement there?
Yes. Well, we're assuming this is where the utility is going to be located, right in there. That's the low voltage and the high voltage utility. That's the first point you need to coordinate when you have a project manager. Or a designer. You need to coordinate where is the power coming from. Why did I bring that trench up there, not on the other corner. Most likely it's based on the way the building is set, this is the back. Most likely it's going to be coming from the back, but these are the points that you have to verify. Where is the utility located relative to your building? So you can bring your low voltage. When they say utilities, I mean low voltage and as in data and phone, as well as power. So that's and TV, cable TV. So these are the points we decided that the low voltage and the utility is going to be in that corner in the north. Any question, guys? So we're bringing a conduit, so we bring power into that conduit. We're bringing that power to the building. Then from the same building, we took a chunk of power here, and we fed, I don't know if you guys can see it, right in here, and we fed a swimming pool. We have a swimming pool structure that we need to feed that swimming pool structure. So what do you think we're going to do? We have a pump there. We have a heater, because we're going to heat this, we're in Minnesota, we're going to heat this swimming pool. We have lights by code you have to put there. You have receptacles by code you have to put there. So we get into, our students get into swimming pool design, basically, bonding and grounding. You guys are going to spare you this hassle here. But that's a different structure that you have to feed. Any comments, questions about that one? And the last trench that we're going to be trenching is we're going to take right in here. These are 4-stall garage building. Each tenant is going to have his own stall, so we need to power and light these stalls coming from the building. The way we design it, every apartment is going to power and light their own stall. So what you're looking at going to this building is basically a conduit, multiple conduits going from every apartment directly into their own stall, and they're feeding it for the garage door opener, for the light, for the receptacles by code. And we'll talk about this one, guys, what the rules are. Any question about this? So that's basically what we call a site plan.
With the residential home, where it's just maybe a single or two family, would they mainly try to trench to the closest point to where the utility is then? But on the side of the house or the back of the house, if possible?
Yeah, now we design it the best way, which is going underground. You don't have to go underground. You can go overhead too. So that line that you see from the top, from the north, right in here, all the way to the building, we decided it's underground because the best design, we're engineers, we want the best design for the customer. Underground, but for apartment buildings, most likely will be overhead. So what you see exactly is going to be the same thing, except it's going to be overhead. Power line coming to the building with a mast, they call it. Really nothing will change other than you don't have a trench and you have a cable hanging in up, power cable coming to your building, and right next to it with clearances or telecommunication cable. So any comments, guys, about this? So that's power coming into the building, going to the structures. Then we go deeper into, zoom deep into the swimming pool structure and the garage. You guys are not doing swimming pool. The garage by code, if you have a detached, you guys have a garage in your building, in the building that you have, attached or detached. If you have a detached garage by the National Electric Code, I don't know how many of you guys have seen this document, the latest and the greatest. In our state, this is a law as of August 8th of last year. We adopted this and becomes the electrical law in the state of Minnesota. So that's what you're going to adhere to, all of us. So when we come fight with you because you violated the law, we're talking about this law, and it becomes a law when we, our legislators, adopt it, like the building code and every other code. So this is the electrical law in the state of Minnesota as of now, 2011, the newest version. Every 3 years they update it. So based on the code, if you have a detached garage, you don't need power for it. By the way, the code says if you don't have you have a detached garage, you don't have to have a power for it. But if it's attached, you have to. So, but if you decided to have a power for it, so the bare minimum for power, you need at least one receptacle, bare minimum, a light, at least one light, and if you have a service door, well, in this case, we don't have a service door for these garages, you have to have a light above the service door so people can get in. These are the bare minimum. Can you guys see how far we went above the bare minimum? We went, the code says one receptacle, GFCI, and one light. Of course, the light needs a switch, so you need somehow switching that light. So here's a switch, is a switch with it. And one receptacle, one light, one GFCI receptacle, one light, one switch done. That's the bare minimum for the code. You can see the style what we did. We added more receptacles because we wanted people to be convenient, right? you be able to utilize the garage really good. But it's an apartment though. And we added another receptacle. I don't know if you guys can see here. We oops, we don't want this one. We added another receptacle, which is right in here. This is for the garage door opener. Didn't change the color. For the garage door opener, and a bunch of other receptacles for convenience. So if you have a garage, what do you need? GFCI, one GFCI receptacle by code. You need one light, one switch, done. And this is, I'll talk about this one, guys, the requirement in a second here. So keep this in mind as we go through. Any question? I want to spare you the swimming pool, just because we don't have a whole lot of time.
Sure. So the garage light that you're talking about, like a utility door, if there's a utility door, that'd be on the outside.
Outside, yep. Outside light for the utility door, if any. If you don't, then you don't need to. Okay. The second one, guys, is so speaking of the garage, as long as we're on the garage, I don't know if I have okay, I don't have the garage on my list. Oops. Okay, so if you guys write to yourself the garage, one GFCI receptacle and one light with one switch minimum. That's a requirement. Circuit wise, you can circuit it with everything else, but you really don't you can add it to anything else in your circuit. You don't have to have a dedicated circuit for it. You do not need a dedicated circuit for it, though a good design would be a dedicated circuit.
Yeah, my
Dedicated
bathroom GFC is somehow attached to my, so on the bathroom, the hair blower or whatever trips the circuit or something, I can't open my garage door.
Yeah.
I mean, I fixed that. Over the years, I fixed it, but that's what it seems like that's what always happens.
Yeah, yeah. Okay, so that's my garage. If you guys go to the upper power, we have in this building we have bedrooms. I don't know if you can see here. These are all my bedrooms here. My bedrooms are here, and we have I'm sorry. This is a family room here, and this is my kitchen. And I will as long as we're here, guys. If you look at bedrooms, I give you that little sheet that you have. If you look at the sheet that I gave you, will you? If you look at this, because this is really nice to go over, and I'm going to go disregard this, and I'm going to go fire the same sheet that you guys are looking at here, so we can be all on the same page. Okay, so can you guys see you're looking at the bedrooms, right? Can you see what the criteria for bedrooms? It says receptacles. If you have a dwelling bedroom, you need a receptacle every 6 feet. 6 feet from every opening and 12 feet between all the receptacles. Start from the door. Measure 6 feet with the first receptacle, then 12 feet the second receptacle, 12 feet the third receptacle. When you hit another door, now window, make sure you're not more than 3 feet away from that door. That's the criteria for bedrooms. You guys understand when I say 6/12? You say one receptacle every 6/12. 6 from every opening, 12 in between. First receptacle, 12, second receptacle, 12, third receptacle. When we reach the end, make sure you're not more than 6 feet away from an opening that goes all the way to the floor, meaning a door. Does that make sense, what I said here? Okay, I'll show you in a second. Then, light.
If you got a window, let's say you got a window.
When do you know?
Maybe to only 12 inches above the floor. A special window, tempered glass or whatever.
Yeah.
And it's a big window.
Doesn't open.
Maybe in a living room or something like that, but.
Well, how about if you have a glass wall?
Glass wall. Okay.
How are you going to put it in a glass wall? The code allows you to put them in the floor, as long as you don't go more than 18 inches away from the wall. So if you can't put anything in the wall because of a glass wall, I'm not going to bust that. It cost me an arm and leg to bust and make a receptacle in a glass wall, right? So what they allow you to do, go from the wall no more than 18 inches and put it in the floor to meet the code. So that will treat this one exactly the same thing. You go 18 inches, meet the. You guys have a glass wall? So that's how you're going to meet the criteria for this one. Okay. So
the receptacle location on the wall that needs to be up 18 inches as well, right?
The receptacles, it depends. For most of the time, a foot to center. You put your receptacles a foot to center.
Okay.
But there's no code requirements other than American Disability Act, where they want you to maintain them. You guys will do that. You maintain the receptacle is not a big deal, but the switches are 42 to 48, I think, or 46 inches, the switches, so people in a wheelchair can reach to it. So the only thing really height-wise, that dictates is the American with Disability Act. And that's not code, that's building code. That's not electrical code.
Okay.
So as far as the code concerned, if you put a receptacle, as long as the receptacle 5 feet, 5.5 feet or less, that receptacle meet the criteria. Most of the time when we put our receptacle, though, we put most of the time a foot on center from the floor. Any question, guys? Any comments? Okay, so here's one receptacle. Everybody knows what the criteria of 6/12. That's the most important thing. Then light. For the light, I would put more. By code, you need one light, but it's a good idea to put a fan. So we end up in a bedroom putting a fan light. It's up to you guys to put the fan, but a light must. Cool. So you need a light.
But the difference is the box itself, right? It's got
Yes.
a metal box,
Yes.
a heavy-duty box.
Thank you. If you put a fan, then the box have to be a box-rated fan. Bigger fan, bigger box, more steadier to handle the fan. So, but what you need is just a light. But common practice is to put a fan there. Okay, switches. For switches, and this is a criteria, guys, in the bedroom. I need 2 switches, assuming there's 1 fan and 1 light. So 1 for the fan, 1 for the light. Phone outlet. The phone, oh, by the way, speaking of phones, there's nothing in the code says anything about the phone. The only thing in the code says phone-wise is you need 1 phone outlet in the whole apartment or house, just 1. So what I give you here is the code and best practice. Does that make sense? Best practice in a bedroom to put 1 phone and 1 TV for those of us other than my wife who likes to watch TV in the bedroom. It's really nice to have a TV. I'm sure some of you are laughing, Chad, while we're getting rid of our phone lines now and we're using cell phones. Believe it or not, after everybody moved away from the phone line, the code enforced that you have, as a construction electrical contractor, you have to provide a phone line because people are not providing phone lines at all because of the cell phones. So in the past, just in 2011, 2008, they start enforcing that you have to have at least 1 wired phone line in the building, at least wired. Because of cell phones, people are not providing any phone at all. So they want to force that you have to have that copper wire coming to your building. Anyway, so TV 1, circuit. I say 1 circuit, guys, and all the receptacles, circuits, 1 circuit to that area, even though you can add other things to the circuit. And do you see, anybody knows an AFCI, arc full circuit interrupter? In 2008, they expanded the use of a receptacle, a circuit breaker that's called arc full circuit interrupter. As far as you're concerned, here's what concerns you. Just to give you an idea, an arc full circuit interrupter, 20 amp, is $40, dollar-wise. A non-arc full circuit interrupter that does the same job is $7. So do your math. So that's why it's a big deal. Arc full circuit interrupters is a big deal, dollar-wise. So imagine if you have 20 of them, multiply 40 by 20 or 7 by 20. As electrical, when you guys do estimating, that's make a big difference in the price. So everything in this area have to be arc full circuit interrupter. So when you put the circuit and you feed all the receptacles, all the lights in the bedroom, it has to be arc full circuit interrupter. Any question, guys, about that? So that's the criteria. As long as I'm on the...
What does the arc fault actually do versus a...
Thank you. Arc fault, the firefighters, arc fault looks at an arc in a circuit or an equipment. So not short circuit. What's the difference? If you vacuum, if your wife or significant other asks you to vacuum like my wife would, that's my duty. And if you're lazy, you want to stretch that cord all the way to the corner. Anybody does that? Just stretch it to get that little corner. Versus what? Versus unplug it, turn it off, unplug and put it somewhere else. Okay, if you're trying to do that or yank that cord out, it will arc. If you have ever seen it, that will arc. That arc will trip a circuit breaker, an arc full circuit interrupter. But the idea is, guys, if you have a device that's arcing, the arc is not going to be detected by a regular circuit breaker. It's just by design. They call it low amp, but low amp is not going to be detected by a circuit breaker that looks at a high amp. So what's the problem? You can have an arc in the wall or an arc in an equipment that sits there, arc, arc, arc. What happened after a while when you are arcing? If you have combustible material around you, you create a fire. So you will burn the building before the circuit breaker wakes up. That's what an arc does. So you take a hot and a neutral, and they're not touching, they're barely touching each other, enough gap between them for a little bit of arc to have it between them, right? That's what an arc is. A receptacle, loose receptacle. Have you guys ever opened a receptacle and you see it's burned in the back? The connection is loose on it. It's arcing over time. If it's in a box, you're not going to create a fire. But if that was a cord, for example, and there's a carpet right to the top of it, imagine the people how they abuse. A lot of people abuse electricity cords, and that cord is frayed and it's arcing inside it. That can easily ignite the surrounding, create a fire. The smarter that Chad came up with this technology, and they said, well, now we're gonna charge you $40 versus $7 to protect you from an arc. It becomes the law. That was very controversial, guys, among a lot of engineers and electrical contractors too. Okay, protect you from an arc.
That's just the breaker itself, though.
The break, yeah. You would, well, probably you could recognize it, but it looks like a breaker, typical breaker with a little bit of characteristics for it. What they do is they have electronics in it, and the electronic is looking at a signature of an arc. A signature of an arc, if the signal is so shaped in a certain way, based on the analysis, the electronic analysis that they do on that, they say this is an arc. That's why they have a lot of nuisance stripping sometimes. They're not smart enough to distinguish between an arc that I like and an arc that I don't like. So that's why it's controversial a little bit, some of it. Okay, if you guys go to the hallway, and we're going to take you to the hallway, the code says you need one receptacle for every 10 feet. One receptacle for a hallway that's 10 feet or more. So if you have a 100 feet hallway, I don't know why would you do that in a residential dwelling, one receptacle. If you have a 10-foot hallway, one receptacle. 20 feet hallway, one receptacle. Not every 10 feet, just one. If I have a 9-foot hallway, do I need a receptacle? By code, no. But is it a good idea to put a receptacle? Yes. I mean, what's the difference between 9 foot and 10 feet? But they have to draw the line. So every 10 feet, that's a code. I encourage you, if you have a hallway, good design, throw a receptacle in it. Okay, so that's the hallway. No fan. You need a light. You need a switch for the light. Can you guys read the criteria for the hallways? And you need a circuit, and it has to be an arc fault circuit interrupter. It's not a dedicated circuit, though. You can add the light to the bedroom circuit. Not a big deal. Doesn't have a circuit does not mean a dedicated circuit. Just a circuit. Any question, guys, about this? The hallway. Let's go to the living room, and we'll show the criteria. The same. Can you guys see the 6/12? The same way. 6 from every opening, 12 in between. I need one good design, one fan in the center, one light in the center, 2 switches, fan, light, right? And if you go all the way, let me put it this way here. If you go all the way, you need in the living room we have one phone, one TV, and one circuit, and also arc fault. So I summarized all these places for you guys. Let's go to the bathroom. Any question about the living room?
If you went with, say, 4 can lights, do you still have to have the one in the center? If you go in
this is the bare minimum. No. Now then you get into a few. If the bare minimum is just one big light surface mounted in the center with a switch, the bare minimum. Now what's recommended, and if you want better lighting, remember we talked about lighting last week? Lighting is a whole science. I want better lighting. Lots of people have cans. If you have a can, the criteria for in residential is 4 on center to get good distribution. 4 on, if you grid them 4 in center, you get really good distribution. You can stretch it to 6 on center, but 4 to 6 on center. Are you guys following me? So you go from the wall here, 3 feet, put the first one, 6 feet or 5 feet or 4 feet, depending. I would say at least 5. Or at most 5 feet with the second one, 5 feet the third one. When you go the other wall, make sure you're not further than, say, 2 feet from the other edge. Okay, so that 4 on, I call it always 4 in center. Okay, any comments, guys? Any questions? Yeah, so that's a bare minimum, just one light in the living room. You're also right, we can put cans. Looks nicer.
And they don't have to have, it doesn't have to have one in the center then if we don't want.
No, you have to have one light.
Right.
Yeah. If it's one light, most likely it's going to be in the center. Now, if you have more than one light, be my guest. Lay them up the best way. The best way when we talk about even, did you guys see what when we did the even distribution? Then you get into the even distribution of light. Residential rule of thumb, usually, if you have two lights, how would you lay out two lights? You know, you divide the same thing. The rule for laying out lights, if you have more than one, you have the distance between the light and the wall is half the distance between the two lights. That's a rule. And then you grid them. If you don't know, as I tell you, 5 feet on center to 6 feet. If it's surface mounted, probably you can go 7 feet. Surface mounted give you more light. But if it's cans, I would say 4 to 5 feet on center, you're good. On center, and then from the wall, it will be 2 to 2.5 feet from the wall. Okay. All right. So this is. Let me just go back to my presentation here, guys, and show you what we're saying. Here's the criteria. Look at the door here. I don't know if you guys can see the door. You measure the 6 feet right from this door. Can you see that? Here's my 6 feet. Then the 12 feet here all the way, and you go around the corner, and this should be no more than 12 feet. What happens if it's more than 12 feet? What do you need to do? Stick another receptacle. That's the criteria. Does that make sense? And wherever you say 6/12, that's what the criteria. Then you keep going from here along the wall. This will be, what do you guys think this will be? 12 feet. Then you go along the wall here. What do you guys think this should be? No more than, I'm not going to say 12 feet, no more than 12 feet. Can you guys see that little edge from the closet? I have a closet here. This distance from here, can anybody tell me it cannot be more than what? 6 feet. So at the end, you have to apply the 6 feet rule. So you can't be more than 6 feet from the edge, from the wall, the door. And then, I don't know if you can see that little area here. Start from here all the way to here. Can you guys see that? There's a receptacle here. The code says, this is a special rule, if you have a wall 2 feet or more, 2 feet or more, in any of these areas where it says 6/12, 2 feet or more, you have to have at least one receptacle. Right? Because that little wall here, in any area that has the criteria where it says the criteria 6/12, wherever you see the 6/12, that rule applies.
It's kind of awkward in that spot, but it meets the code, right?
Meets the code, yeah. And believe it or not, that might be the only way access to that receptacle, the only way where you can access a receptacle in that room after people put all their furniture and all their junk there. It's highly unlikely. Yeah, it's highly behind the doors, guys. We used to say don't put receptacles behind the doors and so forth. But after people put their furniture and junk in the room, it might be the only receptacle almost you have access to it if you're vacuuming or doing some work because of the furniture layout. Obviously, if you know where the furniture is going to be laid out ahead of time, it's really nice to adjust them where the bed is so people can plug in things are. So, but as now we have no idea where they're going to put their beds and so forth. Any question about this?
And that's minimum too. So
That's minimum. Oh yeah, that's minimum. Absolutely. Any question, guys, about this? No, doesn't matter. Yeah, yeah. But I will, if I have my option, I will start from the main door to the right or to the left. Does it really matter? Start from the main door. Like there's 2 doors here, closet, and there's the main door. Start from the main door to the room, and do your calculation. Do 6/12. Any question, guys, about that? Okay, so we covered the bed and the light. I don't know if you guys can. This is not. We're not showing light here. I'll show you light later on. I'm going to say the hallways. I don't know if you guys can see the hallways here. Okay, let me see if I can escape this. Okay. No, I don't want to add that. Okay, close that one. Oops. That's a big line, huh? All right. Trying to get rid of my annotation here. Okay. It should go there, buddy. I don't want you. Okay, wow, still carrying me. Okay, I'm going to work on the other side just for the sake of the time. I want to show you can you guys see, this is a hallway. Can you see the receptacle in the hallway? By the way, these are 2 apartments. So from right in here, This is how the apartments are divided. 2 apartments. Can you guys see that? Everybody see that there's 2 apartments. So I'm going to go the other side, which is identical. Can you see the hallway? There is a receptacle in the hallway. Here's a living room. The same thing, guys. A living room here. All the receptacles are laid out the same way. Okay. I want to emphasize one circuit. I want you guys to look at this circuit here, coming from here to this receptacle, and there's a home run coming right in here. That's what we call it, a home run. So I have 1, 2, 3, 4, 5 receptacles. How many receptacles can I put in residential on a circuit or lights? Up to 13 receptacles. Up to 13 you can put on a circuit. 13. What's the good? Now that's how the max. What's the good criteria for putting on a receptacle? 9. 9 lights or receptacles or mixture of both. One more time. So if you want a criteria, I'm going to say the max, since we're talking about max here, max receptacle. I'm going to put 13 based on calculation, and I'm going to say a good design. I'm just going to say, since you're designing good stuff, design. I'm going to put design. I'm going to put my design at 9.
And that be based on 15 amp breaker, right?
These are based on 50. Now, in residential, you wouldn't go 20 amp breakers unless you have to. You would never go 20 amp breakers unless you have to. Because if you do 20 amp breakers, you have a number 12 conductors. Number 12 conductors is hard to work with. So these are based on 15 amp. But you wouldn't go, if you go 20, you can get higher, but it will be really, it's not, in my book, it's not worth it because bigger wire, more expensive. Unless they tell you it has to be number 12, it's number 15. Okay? Any question, guys? And by the way, can you add the same criteria for lights? So if I have, now, do your best. I mean, if you're in an area and your circuit says, oops, there's 10, and Chad says 9. Add that 10. Remember, the max is what? 13. As long as keeping the max in your mind. If you're very close to, I would say 12 or 13, it might be a good idea to split the area into 2 circuits. You know what I mean? But I always say, use your judgment. These are the criteria.
And you can combine power receptacles with.
You can combine,
and
you can combine the lights and receptacles in dwellings. In commercial industrial, you can by the code, but it's not a good idea. It's not recommended. We always have a lighting panel and a receptacle panel. In residential, we have 1 panel. They're all coming from the same panel. As a matter of fact, because of the arc fault circuit interrupter, I encourage people to combine them because you end up with a cheaper installation. $40 circuit breaker. If you separate them, you might end up with 5 receptacles in 1 circuit and 3 lights in another circuit. So what if I bring the 3 lights and 5 receptacles, put them in 1 circuit? I saved myself $40. And that's okay, no problem. Any question, guys, about the criteria here? Okay, I want you to guys to go to, let me say yes and then I can delete it. Okay, let me go to the criteria, and the time is catching up with us here. Let me go to the kitchen, because the kitchen is very important. Can you guys see where the kitchen is here? The kitchen. I want you to look at the criteria for the kitchen. The criteria for the kitchen, everybody can see where the kitchen is? I need the same rule, 6-12. Do I need to explain that one? Everybody knows what 6-12 is. The one right underneath is the countertop. They need you to put 1 receptacle every 2x4. I call it 2x4 because we remember the 2x4, right? 2x4. In the countertop, you go from the edge of the countertop and you measure 2 feet. You put the first receptacle. If this is the sink, I can't go more than 6 feet, less than 6 feet away from the sink. Then you go to the other side, 2 feet. You put the first receptacle, the second receptacle, 4 feet. 4 feet, 4 feet, 4 feet to the edge of this the countertop. Make sure not more than 2 feet. Does that make sense? 2x4, 2 from every opening on the countertop or the edge of the countertop, and 4 in between. Does that make sense? Yes, no? So that's basically the criteria for that one. I'll show you in a second how it goes. By code, I know this is where you need a 20 amp circuit. 20 amp circuit. Oops, what did I do here? 20 amp. These circuits, guys, have to be 20 amps. Now, in the kitchen, by code, you have to have at least 2 circuits. And I'm sorry, I say switches here. Okay, let's go to the switches. You need a light, and some people put fan too. Light fans, good idea. Circuits, I'm going to go phone and TV. Good idea to throw a phone line, but people with cell phones now is an issue. Circuits, you need 2 circuits. These are special circuits. They are 20 amp circuit. They're 20 amp circuit. And look at this, guys. Can you see any arc fault circuit? Do they have to be arc fault? No. These are 220 amp circuits in the kitchen by code. They don't have to be arc fault. Okay? Any question, guys, about the kitchen? Any question about the kitchen? So that
because you might have 2 flour or 2 coffee pots that drain a lot of electricity. And
yeah.
You want to stagger the layout of them too, where you don't have to. You can have all on the north wall and all the other circuit on the east wall. Or
no, by code you have to bring the 2 circuits to the countertop. So if you have 2 circuits, you must have 2 circuits. So you have to bring them to the countertop. So if I go if I go, my building is right in here, and here's my countertop, and I grab my sink right in here, right? Okay, here's my sink right here. Then I'm going to go 2 feet. Remember that 2 feet rule? 2 feet, and you're going to put 1 receptacle here. And I'm going to go 4 feet. I'm going to say this is 4 feet, and you put your second receptacle here. And at the end, from here to the edge, make sure it's not more than what?
not more than 2 feet.
No more than 2 feet. And then you start from the other edge. I'm going to put my receptacle here.
Otherwise, you put a 3rd receptacle in there if it's like 3 feet.
Yes, you have to. Well, yeah, it's not a big deal, but you add more receptacles. Okay, so that's how you lay them out. Now circuiting by code. Here's how you circuit them. You bring 1 circuit here. You have to bring 1 circuit and another to feed these 2, and you bring these 2 on another circuit. And then if you have a receptacle, this is a kitchen. You still have to have receptacles all over, right? Suppose that door, my door is right in here. So
don't have to be 20 amps there then.
all of them have to, everything is going to be fit from these 20 amps. So suppose this is my all other receptacles in the wall in the kitchen. Remember, the rules still apply. The rule, what's the rule on the walls?
612.
Thank you. This is 6. And this is in between them, measured around corners is 12. So what I would do, guys, is I grab these 2, feed them from 1 circuit, another circuit, and these 2 from here and here. So this is my home run. Home run 1, home run 2. This is a 20 amp by code, 20 amp circuit, and shall not feed anything other than the kitchen and dining room. These are, I call them sacred cows. They can't feed anything other than the circuit. Does that make sense? So here's how you wire, layout and wire receptacle. Yes, sir. Yes. Now you guys are, if you have an island, 2 by 1, 2 feet by 1 or more, 2 feet by 1 or more, 1 receptacle. Peninsula, right? You have to have you know what a peninsula is? It stretches a little bit. Same thing. If you have 2 feet by 1 foot or more, you have to stick 1 receptacle. Now, what are you going to put it in an island? Usually on the side, in the carpentry.
Yeah, you don't want to have it face up where you can spill something in.
Believe it or not, they have an assembly that you can install in the countertop. But it's an assembly. It's not, you buy it. It's basically everything is manufactured, and you just tie the wire to it. And you push it up, and it goes up, and you push it down. It's like a tube, and the receptacle goes down. And when you need it, you push the cover, it goes up, plug into it. When you're done, push it down, sealed around it. So.
In a sense, some of our desks are kind of like that too. We've got
Yeah, like the ones in the desk. Yep, absolutely. But it's an assembly. When we say an assembly, it has to be listed and manufactured. You can't just design it and have a box yourself and install it. Any question, guys, about the kitchen? These 20 amp circuit, I call them sacred cows because they can't feed even the light in the kitchen. Write yourself a note. Cannot be fed from these 20 amp circuits. Only in the kitchen. The light cannot be fed from these 20 amp circuits. They cannot feed any other place these 20 amp circuits except a dining room. If you have a dining room, you can feed them from these 20 amp circuits. Any question, guys?
GFC for like.
All of them, yeah. GFCI, I put GFCI, guys. Okay, so these are the layout. Very good point. If they are, I think I indicated it right here. Can you guys see where, let's go back here. Can you see where I said GFCI? Everybody can see that line here, GFCI? On the countertop, GFCI. Not on the countertop, no GFCI is required. Is it wrong to put a GFCI? No. Is it a good idea? I don't think so. In a kitchen, I mean, it's, you have to kind of the optimum design. The optimum design, I would go by GFCI on the countertop, non-GFCI on the kitchen. Okay, any question, guys, before I'm looking at the clock here? So that will help you with design criteria.
You've got some specialty outlets and stuff like that, obviously, in the kitchen. If you got electric
Thank
stove
you.
or something like
Thank
that.
you. A couple of things. Do we have the stove here? I don't have a stove. No. If you have a stove, you have a 20 amp. Most of the time, you have a stove, you have a 20 amp circuit. Let's go back to the kitchen here. Criteria. So if I have a 20 amp, you have a stove. Oops. Where's my? I don't know. Okay. I lost my pen here. Okay.
Do those types of circuits need to be dedicated to them?
Yes. Yes. In the kitchen, you have a stove here. If you have a stove or a range, we call it range. Range, you need a 20 amp circuit. 40 amp circuit. 40 amp circuit. 40 amp circuit for the range, for the most part. And these are two circuits, kind of two pole. You know what a two pole is? Two pole. If you have air conditioning, AC unit, not window, that's the central air, then you also have two circuits coming to that area. This circuit, typically this is a 30 amp. I'm saying typically, guys. These are circuit 30 amp, 30 amp. The wire here is typically number 8 conductor. 3 conductors, number 8. And these are typically 2 conductors, number 10. Number 10. Everybody knows the wire gauge and all this good stuff?
I can talk with them about that too.
Yeah, 14, 12. You start with 14. If you have a 20 amp, always 14. If you have a 12, if you have 15 amp, 14. If you have a 12, conductor 12, 20 amp. And number 8 goes with 40, and for you guys, number 10 goes with 30. It's a typical. Any question, guys, about that? Tim, does it make sense?
In the kitchen, how about like a disposal or the...
Yeah, garbage disposal. You have a garbage disposal, 20 amp dedicated circuit. These are equipment. You have an equipment, garbage disposal, and let's just say if you have a garbage, here's another equipment here, garbage disposal, or how about dishwasher or dishwasher, right? Dishwasher. These guys are dedicated 20 amp circuit. This is my 20 amp circuit, and this is my 20 amp circuit.
Does the refrigerator need to be dedicated?
Doesn't have to. No.
How about that one thing, the
Microwave. The microwave.
a microwave and then a regular oven too?
Regular oven, dedicated circuit. Microwave, 20 amp dedicated circuit. You have a microwave built in the microwave, dedicated circuit.
When you say dedicated, that's not what
Yes. The word dedicated means it's feeding only that individual load. It doesn't feed anything else. Everybody knows that? Dedicated? Yeah. Any question, guys, about this? I'm looking at the clock here.
Probably bathroom would be if we had a little...
Yeah, I'm talking about the bathroom in a second. Let me just walk with the criteria, guys. Dining room, the same way. Same criteria, guys can read it. I want to emphasize utility room, bathroom. Where's my bathroom? Here we go. Bathroom. I skipped the bathroom. In the bathroom, guys, you need at least one receptacle, 120 amp circuit feeding that receptacle. And you have a light. You have to have at least one light, one fan, the exhaust fan receptacles. And I don't know if that's it. So in a bathroom, 20 amp circuit feeding The receptacle have a light and a fan in the bathroom if you want to. One receptacle for the fan, one switch for the fan, one for the light, and one GFCI receptacle at least. Any questions about the criteria in the bathroom? They have if you have utility room outside, utility room, you guys can read the GFCI. Outside, if you have a dwelling room, by code, you have to have one receptacle on the front of the house, one in the back. When they're outside, so what do you need to do? GFCI, and they also use in-use cover, that bubble. If you guys have seen them, that bubble, they call it in-use cover. Anything you put in a wet location, by code, it has to be in-use cover. In-use cover. AC, we talked about the AC, guys. Closets, I threw a closet, stairway, and storage just to give you an idea. We don't need receptacle on them, and so forth. We need light though. Any question about this criteria? Any question about this criteria that you guys have? Everybody has a copy of it? You should have a copy of it. Okay, let's just go back into our stuff here. I'm just going to show you the bathroom here. I don't know if you guys can see. Oops, there you go. Let's go to the lower level. Let's grab some pointer here. Here's my bathroom. I don't know if you guys can see. Let's look which one is a good idea to do a bathroom on. Here's my exhaust fan is here. My receptacle for the bathroom is here, and dedicated circuit for it. So, oops, these are not my receptacle. Okay, let's go back into the receptacle. It's hard to manage these. Okay, 1, 2, 3. Here we go. Light. Let's go to the lower level because it's very similar. Lower level. Here's the lower level. I'm just going to show you the receptacle for the bathroom. Here's my. Can you guys see that receptacle for my bathroom here? Is right in here. And what else? I don't know if you can see right here when you guys get the PowerPoint presentation. Look at this is the kitchen countertop. That's where the criteria is assigned to the kitchen countertop. Okay, so that's basically my kitchen countertop requirement and so forth. We have heaters in this. This is very busy utility. We call this is the utility room. So I'm going to spare you guys. You have only one house, right? Or apartment?
We have just a 1 2-story house.
1 2-story house. So we spare you the utility room. If you have an apartment, you have to have a lot of coming places for the apartment by code. So we'll spare you that one. I'm going to go back into lighting. This is my lighting. When we were saying in the bedroom, there's a fan. Can you guys see the fans in the bedroom here? There's a fan in every bedroom. There's can lights, fans. In the kitchen, we have some type of fluorescent surface-mounted light here. So that's a couple of places you have to. Hallways. I don't know if you guys can see the hallways. We decided to put lights in the closets. Can you guys see the closets here? We decided to put lights. You don't have to have. Not necessary, but it's a good idea to see. So these are the lights for the lower level. Low voltage. I don't know if we decided, are they doing security system for the building? Are you guys doing?
Not security, but like safety, like carbon monoxide.
Yeah.
Or
Yeah. You need smoke detectors. I'm going to highlight this one. These are my 3 wired smoke detectors. By code, you need smoke detectors in every bedroom and in every hallway that opens to a bedroom and in every level. Every bedroom, every hallway that opens to a sleeping area. And every level. So if you have a basement and a first floor, you have to have it in the basement and the first floor. All interconnected with a battery backup. All interconnected with a battery backup. Phones, we talked about the phones. We have security system in this building. You guys are not putting a security system. Okay, so here's my lower level lighting, low voltage. A couple of schedules that we do for everybody knows what a schedule is, guys? Right on the panel, you have to identify every circuit breaker that switches which area. So for maintenance, remember, you build, I always tell my students, you design a building that's going to live at least 50 years commercially. You know, you're talking about a building that's going to outlive most of us. I'm 43 years old, so 50 years, I don't think I'm going to make it. Some of you guys probably will be around, but Tim and I wouldn't be 50 years from now. So think of the poor people who are going to be maintaining the system 50 years from now. So that's what I always say, do a good job. This is a couple of risers, guys, that we do and cut sheets and so forth. And I'm going to spare you. Here's a couple of shots. You'll see, we'll get this one in the PowerPoint presentation, guys. The couple of shots, feeders, and so forth. And I'm going to stop right here to respect your time and mine. Any question, guys? If you want to, I know you're not an electrician, but I strongly encourage you guys, if you want to go, you will get this one, tell my email to you so you can email to all of them. But please go to YouTube and look at, if you understand how the system is put together, there's a lot. There's 4 presentations if you're interested at one time, look at it. Also, if you look at the design more deep into the code, we have tons of stuff there. Tons and tons of stuff on YouTube. So
Chad, if you get a chance to, I mean,
and this will be on YouTube
that
too.
AutoCAD drawing for the civils, if you would
Okay.
attach your link to your website too, and to your YouTube.
Okay.
So with that AutoCAD thing, then if it's okay with you, I'll forward that onto the other students here too.
Okay, no problem. No problem.
And then we shouldn't be asking you any more questions. We'll just go to your YouTube to find the answers.
Absolutely. There's a lot of stuff, guys, if you go to the playlist there for design, load calculation, drafting that we do from an electrical point of view. But understanding the power system, really good, where is it? Basic, here, basic electricity. Good for videos that there, basic electricity, series circuit, parallel, and so forth. If anybody wants interested in that one. So,
Well, thank you.
yeah,
Chad.
thank you.
Now, you guys, I think, did John Stevens give you guys some kind of assignment for the next hour? I'll